Welcome to Mathematics 1, FMA 0116, Chapter 2, Equations, Inequalities, and Absolute Value. This video is going to cover 2.1 equations. We are only covered three types of equations, surds, indices, and logarithm. Okay, for equations involving surd, okay, we try to get rid of the surd. Okay, how we want to get rid of our surd? Okay, let's say our left hand side involving one certain surd and our right hand side have some other surd. So what we need to do is we squaring both sides. Okay, so squaring both sides. So at least our left hand side the surd will be get disappeared. Okay. Okay, now for the second part is indices and logarithm. Okay, so for indices and logarithm, the most important part is you need to be alert with the base. They must have a similar base. If not, try to change the base. Okay, so for the indices, okay, while their base are the same, so we say that their power will be the same. Okay, please don't have the habit of writing, okay, in this way. Okay, it's wrong. Okay, so now what we need to do is we just say that the base are the same, so our power are the same. Okay, for logarithm also the same, that is the base must be the same. Okay, and then later on, then we say that the x and the y are same. Okay, for indices, okay, for the surds and logarithm, okay, because it is very sensitive, that is, okay, because our surd inside cannot be negative, okay, unless it's a involving complex number. If not, our inside the surd cannot be negative. So we need to verify our answer by substituting back into the equation. Okay, look at the first example for the surd. Okay, so a simple one. Okay, when I have a surd 2x plus 1 equals to 5. So since we have one surd only, so we're squaring both sides. Okay, so our surd disappeared. So we have 2x plus 1 equals to 25. So and we obtain our x equals to 12, and always checking back by plugging back our 12 into the original equation, and is equals to 5, so means that it's true. So our x is the answer for this example. Okay, for the second example, have surd, and it's still the same, only have one surd. So what we do is we squaring both sides. So we squaring both sides. Okay, so squaring both sides, the left hand side is 2x plus 5. The right hand side will be getting to x squared plus 2x plus 1. So we rearrange everything. So we get obtain our answer is x equals to minus 2 or our x equals to 2. Okay, now your duty is checking back. Choose x equals to 2. Okay, our answer is 3. So it's true. When your x equals to negative 2, when we plug into the left hand side and the right hand side of this equation, so we will obtain left hand side is 1, the right hand side is negative 1, so is false. Okay, this one is false. So now means that we only have one answer, x equals to 2. We need to discharge our x equals to negative 2. Okay, now we look at the third example. Let's say we have surd 2x minus 7 minus x equals to 2. Also still one surd. Okay, now why we didn't squaring from here? Okay, when we're squaring from here, okay, so means that from here directly you are squaring. What will we, okay, let's say I have a surd a plus b equals to c. If I squaring starting from here, so I will have a plus 2 surd ab plus b square equals to c square. I still have a surd over here. So what we need to do is we need to isolate it to one side. Okay, so let our surd stay alone at the left hand side. So the rest of it we just send it to the right hand side. Okay, so and this one will be very similar to our previous example too. Okay, so you just squaring, and then you solve for your x and y. You solve for your x and you get two different answer. and later on you plug into it, and for this example both answer are true, so this will be our final answer. Okay, let's say we have another example. Now we have two surds. Okay, this is our first surd. This is the second surd. Okay. It will be the same thing, that is, try to isolate one surd at one side. Okay. So means that for this case, I just send my negatives 2x to the right hand side. So we just move one to the right hand side. Okay. Then same thing, squaring. And now we have one surd on my right hand side. So what I did do is keep this one, then the rest of the thing is sent to the other side. So you have this one. So now we'll be back to the previous example. So we keep on squaring. Okay, then until here, the finally the set is all are disappeared. So we use calculator and you get the answer. And always remember, you need to check your answer. Okay, then verify both are true. So our answer is x equals to 2 or x equals to 2 over 9. Okay, so that's all for the third example. So I rephrase is, first we try to get it our third by squaring. And one thing, okay, please one time keep one third at one side, then keep on doing until you finish your third. Okay. So the second one is indices. Okay. So indices, first thing, we check on the base. Okay. This is 9x, this is 3x, but 9 have a similarity or not say similarity, they can change to the similar base. Okay, 9 is 3, but okay, 9 actually 9x actually is 3 power of 2x. Okay, but since indices PMN is equals to PMM, so now I have 9x actually is 3 power of 2 multiple of x. So I still can be writing as 3x multiple of 2. So I just write as 3x multiple of 2, power of 2 plus 23. Okay, this one I send it out. So because since this is a plus, so now this is 3 square multiple 3x. So now we have the similar base is 3x. Okay, so we let our u equals to 3x. So this one change to u. So now we have a polynomial. Okay, power of 2. So quadratic. So we have u squared minus u plus 20. So find the roots of this quadratic. So our u equals to 4 or equals to 5. Okay. Now, but the question is asking for x. So u, we substitute back our u with 3x. So how to get the x? So we just taking the log. Okay. So we take the log left hand side and right hand side. So log here is a log 4. Okay. And the x can come to in front. So x log 3 equals to log 4. So we solve for x is log 4 divided by log 3. Use your calculator is 1.262. Okay. And we doing the same thing for u equals to 5. Similar process, x log 3 equals to log 5. So our x equals to 1.465. This one, because it doesn't matter power of negative or positive, so we no need to substitute back to verify the answer. Okay, let's look at the second example. Okay, checking the base, this is 5, this is 8. Okay, 5 and 8, they will be never have any common factor. So we try to do others way. Okay, so we try to separate the rest of it. Okay, so now the plus 1 will become power of 5. Okay, 8 2x, the 8 2x actually is 64. Okay, then we have the negative 3 going down. Okay, become 8 3. So we have 10. Okay, we have the 5x at the left hand side. right hand side we have the 64x. Okay, so since we have a PM and QM, so actually they can be changed it to become, okay, P over QM. Okay, so that's why we have the 64 over 5 and then the rest send it to the other side, and this one taking the log again, so we have the log 12.8x equals to log 256. So our x equals to log 12.8 equals to log 256. Okay, then is this answer. Okay. Okay. Now we look at our example logarithm. Okay. As all, first thing is the base. Since the base are the same, okay, the only not the same is 1. 1 we always can change to the same base as log 2. Log 2 is 1. Okay. So after we have the all the same base log 2, what we need to do is we just implement our logarithm properties. So we have our log x plus log y is log xy. So this is x, this is y. So we have our log x plus log y actually is log xy. Okay. So now, since both have the similar base, then we say that this x squared minus 10 is equals to 2x minus 1. Okay. So x squared minus 10 equals to 2x minus 2. So then we solve our equation. We have our x equals to 4 and x equals to minus 2. And again, when involving log, we need to substitute our answer back to verify the validity. Since if you, let's say we check our x equals to minus 2, substitute inside, and the answer actually is a log negative and it is invalid. Okay, so it's the answer for x equals to 9 minus 2 is rejected. So now we try x equals to 4 and is you get the answer. So we only have one answer, x equals to 4. Okay. The second one is, okay, we look at the thing, log 2 base 2, this is log x. So first thing is change the base. Okay. Now we easier, so we just change our x to the log base 2. So we have log. Okay, so when we want to change PQ, so we change to the common base log. Take M, the first one is your Q, then log M, then the base is P. Okay, so this one you change. Okay, now this one, just assume this is an Y. Okay, so Y. So you have your Y plus 3P over Y equals to 4. So how to solve it? Just cross multiple. Okay, so I have my Y squared plus 3 equals to 4 log 2x. Just let our log 2x equals to u. So I'm going to have u squared minus 4u plus 3 equals to 0. So my u equals to 1 or 3. And remember, substitute back. What is your u? U is log 2x equals to 1. So my x is 2. Then the other answer is u equals to 3. Log 2x equals to 3. So my x is power of 8. Is 8. So again, we need to check our answer. Both are true. So my final answer is x equals to 2 or x equals to 8. Okay. So now, okay, try it. Okay.